Okay, apparently this should be live. All right, welcome everyone to this week for OffSec. It's going to be a good week. We're going over a bunch of CTF Solutions, so should be a good time. First thing that we've got this week, we actually have a new officer, Logan Stratton. So, originally there were some other interesting things on this slide that Chris and I may have made, something about Jesus and I don't know. I don't really know what's going on there. But yeah, he's already done a lot of stuff with CTFs. He helped pretty much completely run this week's CTF, so he'll be around. Again, we've got that good old questions page, so if you got stuff during the meeting, just fill stuff out there. I'm also going to be monitoring the live stream chat, but it's more likely that things will be missed and we don't actually have that up here. So, all right, coming up tomorrow for Programming Club, it's an actual like ACM programming competition. Should be a really good time. It's qualifying to go to regionals. I see a test message in the questions page. So it's going from 5 to 9. Okay, so yeah, free pizza. Come by if you want food and to maybe go to regionals. There's a no computer club next Monday because we have the day off. DefSec, those dates are completely off, but whatever. DefSec, I don't know. They're doing stuff. They're doing something. And for us, I'm not sure what more has gone down, but we might have someone come talk about some command and control stuff that he made, where he like controls it through email and it sends a shell to him. Like it's pretty cool. Not sure if you'll be doing that. And then in the future, we're looking at having Mark Spanier come by and talk about some crypto. So that should be a real good time. All right, over to Logan to talk about all sorts of CTF stuff.
So as the CTF guy, I thought I'd start off with Code Breakers. It's NSA like CTF that runs pretty much all fall. I think it started like 3 weeks ago, runs for another 3 months, something like that. I think it's a good, like, yeah. It's an L, yeah. So if you sign up, there might be problems with it actually sending your confirmation email to spam.sd.gov. So check that out. It's really slow, so don't expect super fast speeds. It's a good like showing of how many people at DSU are actually like interested in this kind of stuff, and it might get us our foot in the door for more NSA related stuff in the future. And usually, while they aren't the easiest, usually the first couple like get you in there, and then it scales pretty quickly. But if you actually stick with it and actually search and Google, which is going to be a lot of your time, you'll learn something cool and be able to actually talk about it in the future. Next, we have the Hack the Box CTF. Yes, I am single. I'm not sure who put that one in there. Okay, but for the Hack the Box CTF, sometime in November, Hack the Box is hosting a CTF for college only. That's a lot of us. So we actually, I think we stand a good chance of top 5, if not top 5, first place. I think we can do that.
Is Daddy Coco known?
I do not think so, because he's not officially a student until spring, sadly. Thank you, whoever wrote that. Major League Hacking. This is a hacking event that Major League Hacking is kind of just like a hackathon type collaboration group. So this weekend and Beacom all Saturday, we're hosting, if you go here to this link, do you want to toss these slides in? Sure. In OffSec, we'll toss the slides, you can get this link easier. But at this link, it'll give you like a schedule of what's actually going on Saturday, and we'll have AWS hosting website like session, a Unity game engine session, I think there's a third one. But it's all day Saturday where you learn how to like do hack stuff together, not actually hack things. Hack U Iowa, it's another hackathon type thing in Iowa, at University of Iowa. This you can get travel reimbursement to travel there because it's like 6 hours away. They also have housing, so you can stay there overnight. And they have really cool prizes, like $8,000 prize pool for like the top winners. Not like you actually get $8,000 total, but some prizes. So on to the conclusion. This picture's a little bit older, but we had about 80 people play. That's pretty good, I think. It's a round of applause. So a lot of these users, or not a lot, but some of these users weren't actually all DSU. So this was open to other people too. So more people were able to compete and get the word out to other schools. And I think I'll just hop right into some walkthroughs. So how this is going to work is that I'll start off on the easier challenges, and the further we go in, I'll go into the more difficult ones. I don't know if I'll hit all of them unless it's specifically asked for. But if you start to think that I'm going too fast or too complicated, because a lot of these things might require some pre-known knowledge that I might ignore, that I just assume that you guys might have known or looked at. So if that comes up, let me know and I'll try and explain some of the confusion. And then, yeah. So, is there a certain category we want to start with? Yeah. YouTube comments. Okay, so miscellaneous. That's a great category. I guess I'll just hop straight into YouTube comments. So, it says, we only have 2 solvers, Jerbear and Cyclops. So it says, aren't comments fun? So we'll go to this page. You'll classically get rickrolled. While you could go through that and actually look through it, what I would like to do is just inspect this element. And right there you'll see some comment where it says DSU hidden text. Sorry guys. Not too difficult, but it looks like it stumped a good chunk of people. What a hash. Kyle went over that one. You just decode the hashes. It'll give you the text. I think it is real was the password. Something like that.
Like, is it real?
Is it real, whatever. So where am I? Yeah, 187 people couldn't right click on that. Where am I? 8 people, that's a good amount. So, okay, if I open it twice. We see a sign. When this first came out, this was a first challenge 2 years ago. When it first came out, you actually had to go to that sign to get the flag.
It was way longer than 2 years ago.
I remember
Because Andrew.
Well, we did it in our
we did it 2 years ago.
Yeah, and we did it long before that.
Oh my gosh. Okay, so
Andrew made it.
I'm surprised this sign was actually still there because they had a brand new sign right after it. It was kind of weird. But anyways, if you open this up and looked at the geo tag information, you'd see that it's close to, it would say that it's at Wentworth, South Dakota, and Wentworth was the flag for that one. I think that, and then submit me. You just have to submit the flag. Code breakers, I can't really go into that one because it's still ongoing and I'm not just going to give you flags for that. Next category.
The web app ones?
Yeah. So, Web App 101, go to this page. I need to actually remember what. Okay, it wants to know the developer site. So, on this page, you could check the robots.txt, which that's not it. So, robots.txt, there's a lot of web scrapers out there. Okay, I thought it was there earlier. Corey must have taken it down or something. Whatever. I thought that was there earlier.
Inspect all.
So if you inspect the element again, I just go Control U to actually view it all. We'll see a hidden script down here. So if we actually copy that script, I just like to do it in the console. Paste it. This will give us an actual new news tag where we can actually find this developer site right here where it says it's now up and running. We're going to need that for later. So if we give that, we'll get that flag. Go on to the next one. What is the full name of the developer on the team? So continuing with this AJAX call, if we just replace changelog with this new website, we'll get welcome to dev server, it works. But if we change this to from replacing that like specific tag and go console.log, We'll get the source code for that page, which we can see that there's a hidden API at debug.php. So going a step further, we can do debug.php and then name equals developers. We'll get Bobby Tables, which at first that's just kind of a default name for people or for a table, but turns out that's actually the developer's name, so can't question him.
I want an explanation to why you would just haphazardly copy paste things like that.
I mean,
Because sure, it's the solution to the problem.
it's doing deep. So you know, I'll go a step further. So if you get rid of developers, you can see that it says no results for query. Select name from blank.
Wait, what are you asking?
That's specifically what I'm asking, is why you're just copy pasting.
All right, yeah. So
This is going directly into a query.
this shows that it's just taking the name and throwing it into a SQL query. So further on, we can actually take this entire page, which
So, I can kind of explain like the first. So the first thing, just in the API.php like call. So that's what's called an SSRF or server-side request forgery vulnerability. So that's why if you actually try to like go to that dev random.corp.dctf.fun, you try to resolve that, that's going to resolve to an internal address. So you can't hit that, but through the SSRF you can actually hit that internally. So that's that like first step, and then from there is the finding that vulnerable script on that dev server.
yeah. So then, as Corbin said, like I like to think of it as developer sites shouldn't be accessed from external IPs. So you only want to hit that internally, and through this API call, we're able to actually hit that. And then, as Sean wanted me to point out, it's doing a SQL code from this table, select from name. So if we go to the next one, what is the, oh, I must have messed that, oh, there's, all right. 301, what tool should you use to continue? This is kind of open-ended, I guess. You could have used Burp Suite or a bunch of other tools, but we were actually looking for a tool called SQL Map, which will allow you to do SQL injections automatically to figure out what's actually inside a table. And hopefully on this live presentation that this will go well. So I haven't actually done this for a couple days. Which, never mind, it will not work because I'm on DSU's network. But if you were to use SQL Map, I can give you the format. So SQL Map is looking for the URL.
Do you want to make it larger?
Yeah. No, that's not going to work.
You should be able to control Shift plus.
It wasn't working. There it is.
Nice.
Okay, so it gives the URL, so we'll need to also add the first part. And then we can set, okay, developers. And if we add this little star, it'll actually help, say -P for call. So the star will tell SQL Map there's an injectable point here. You might just not realize it because the way SQL Map is parsing this URL, it's going to see call only and not see the name. So that's why you need the star. -A is just say, whoops, do as much as you can, like try dump pretty much everything. -P says what parameter. We're just going to specify call just to make sure. And I think if you just actually ran that correctly, it's like here it's found the star. Say yes, that's exactly what we want to do. It crashes because of DSU's network because it doesn't actually want you to do this kind of stuff on the network.
You might actually have to do the tamper double encode.
Oh yeah, that too.
Yeah.
Go back a little bit. So if we go back a step to the first one, the first API call.
You just hit it in your browser,
Ooh.
it'll probably be easier to see. Rather than doing everything just
Nah, this is way better.
in the console.
Alright, so we can see here, as well it says the dev random, it also says fixed a bug in the API. Some characters in the parameter may need to be encoded more than once to prevent tampering. That is a hint at the fact that we need to use a tamper script called char double encode. I think if I did list, no, okay, whatever. There's a way to actually list them. There's a tamper script. I don't know if that's the right parameter, but there's a tamper script called char double encode, I think, .python, where it will go through your URL or your connection that you want. Okay, I'll get to that in a little bit. It'll go through what you're sending in and actually double encode it. And encode it means a little bit further and further. So when a connection is made, like HTTP, garbage, and then a parameter, and like you had a space or something, it'll change this space to like a plus or %20, because that's the hex code for space. It's just encoding it, so like so the character is going to be sent over the web without having to worry about it being interpreted as something else. So someone asked the question, what's an API call? The best way I can explain it off the top of my head is where a service or a process or a program can create or has these APIs, or I don't know what it stands for. Does anyone know what API stands for off the top of their head?
Application something interface.
Okay, application programming interface or something like that. That's what I was hearing. This allows you to hit this API or page with a specific parameter. So in debug's case, it was name equals whatever. Where if name was set, it'll actually put that name variable into the command call and go through it. So that's kind of just a rundown of what an API is. But if you did Web3, or if you did this with the correct tamper stuff, and then I think you also need to say, like, give me a host name or something. I'm not sure what it was. Again, I'll toss this in the OffSec channel what the actual correct SQL map was. Don't do this to any websites you find, because that's a no-no. It'll get you in trouble. Okay, so with that,
If anyone has questions on it, you can just message me on Slack, because it was supposed to be easier than harder.
so yeah, so that's a lot of pages.
I can just write a short explanation of everything.
So if you hit @CDL on Slack, he's the one who created that challenge and all the web challenges, so he has a good understanding of what's actually going down. Oh yeah, I'll go to the what's up doc was,
Do you want me to just explain that one? And come up there and explain it.
yeah, if you want to.
Sure.
Otherwise we can wait till later because it's a higher level.
We can just do it one later then.
Okay, so we'll come back to what's up doc because it was one of the highest points, is actually the high, no, I think it's tied for highest points or something. But yeah, that is most of the web challenges. Reversing Stego, Pawn, or Crypto. Stego? Okay. 15 solves for Can You See Me? So we'll get this PNG, we'll open it up. Oh, this actually works right away. Can you guys see that? So if you open it up in Linux, it actually show you like the clear text, like there's nothing there, but it looks like in this Windows, it'll actually show you that. It's kind of light. Here, I know of a better way. So what I did actually was open up Forensically, is an online web processing tool, or image processing tool. Go to downloads, Stego. You actually hover over it, just like points it out right away. So there's that Stego for that one.
You can open up in like StegSolve too, and I'll change all like the colors.
Okay, so then it looks like StegSolve will just find the alpha characters, probably the
just all
alpha.
it changes, I don't know, applies wizard filters, and you can just read that in plain text.
Where am I? What am I? Where am I? It's kind of confusing. This one's a little bit thick. Change to CTF, change to custom.
Yeah.
Okay, so we have so if we just look at the file first, so if we do file and where am I, we can see that it's a PNG image, only 960 by 60 by 656, but if you actually look at the size, it's huge, which means that it's probably not actually that. So if you run a quick strings on it, this will just grab all the plain text characters from that are like in a good strings format, and we can see that there's actually hidden stuff inside it. So what I could do is actually look through that to see if there's anything else, but whoops. But yeah, here. So what you can do is move where am I, as you can see I already did, kind of to where am I.zip, and you can unzip where am I, and it'll ask for a password. Right now we don't have a password, so we need to find the password. The only thing we can actually really do is either look through the image itself or do strings again, which, yeah, and search for a password, which we can see that the password, the cake, is a lie. You would be able to find this just looking through the regular strings. It was just like above all of this, which takes a while to actually find. So if we unzip, oof, here it's RM, all the flags that shouldn't have came out. Unzip where am I, and then give it the password. It'll now inflate, so now we have all these flags. Yay us. So if we LS'd all the flags, we can see that they're all look to be the same. So let's open up one of those bad boys. PNG. And we have DCTF, let's have cake. If you were to try that flag, you would find out that that is not the flag. So what we need to do is actually, what I'm going to do is sort them. And now we have two that have different flag values. So if we open up the first one, if you guys ever have a question about any tools I'm using, I can tell you. So then it finds out, there it is. Whoops. We can find out that Dark Rain likes cake. That's nice to know. But if we look at the second one, we'll actually have DCTF, you are so clever, and that is the flag. So yeah, so another relatively simple, but you'd have to look around a little bit and notice that the file was a little bit bigger. Okay, on to the next one. Read what now? Only 5 people got this one. Oh no, this isn't the one I thought it. Oh yeah. So, if you look through this, you might notice that there's 2 numbers increasing and numbers in the middle that are changing, and then numbers on the side and colors. The ones in the middle don't seem changed that much until you're down here. But what these actually are pixel locations, and the colors actually correspond to them. So it says, how do you know that you are so clever is not the correct flag for the last one instead of Dark Rain saying he likes cake? The fact that most of the other, I guess since we tried to keep a consistent-ish flag format and none of the others are in that format, as in spaces in between words, and DCTF is what all the others had for all the other images had for that cake one.
Plus you can just do travel. Or, yeah,
That's true. I know some people like to try as much as they can. So, let's see what file actually had this in. So, I created a little Python script. Yeah, no problem. Challenge 5. Okay, yeah. Zoom out a little bit. Probably do. This is not the right one. Thank you. A little convoluted. I know I have it around here somewhere, but this might take me a little bit to actually. There it is. Okay. No, that one's Rubik's code. Well, anyways, what you would want to do, and if I actually find it, I don't know where B, oh wait, no. Be an NCL, because there's an NCL problem. Okay. So if we open this Python file, I'll use the PIL library, which is the Python image library, which allows you to open files, look at pixels, and create images. So what I do is open the Stego file, read it in line by line, grab just, I closed it. I grab just this middle section because I just wanted to work with the pixel values. Put them down to 255, so I just mod them, or divide by 255 to get like a rough estimate of what it actually looks like. And then I set each pixel value, so RGB, to that pixel value, and then show the image at the end. So that's just some math and some gross Python. There's probably a way easier way to do this, but this is what I went with. And then we get the flag right here, sky-tele 0397. Any questions on that one? Yeah, okay. Story time. This is actually one I just kind of created day before. Gives you a tar file, which for those who don't know what tar file is, it's just another like zip file kind of. So I'll go through on how to decrypt this. CTF custom. Change directory to test. Change directory to story times right here. We'll do tar. XF means extract for gzip. That says F. But either way, if you do that on the tar file, it'll actually extract it to story time, which was hard to tell there because I already had the directory. But it overwrote the last directory for story time. So if we go in here, we have a couple things. We have a README. Just type make to make the program. Some good typing right there on my part. Then you can run it. Don't get too spooked though. So we have a makefile, which for those who don't know what makefile is, it's just a way to easily compile your files. So if you look in the makefile, it just has executable, which is story time, and then these are the processes it does. So it just compiles it for me. So I just do make, and now I have story time, which it asks for a flag, so A, B, C, D. Then it brings us to a YouTube page with music video. And it says, go listen to this and come back for result. But we're not going to actually do that. I don't think I actually have the original source code anymore. It's going to be a problem. So if we open up the actual story time. Okay. If we open up the actual story time though. That was a little Vim thing. That was my problem earlier. We see we actually have a sort of looking story. If you want, you can go read it. I'm not going to read it now. This was written by Gibb. He's not here right now, so can't really give him much credit. But this looks a little weird. Usually C programs don't actually run like this. But if you look up here, this isn't the usual standard io.h. Is make something that exists by default, or do you have to? So man-made. It's not always on every Linux. So the question was, what is make? Yeah, it pretty much is another Rickroll. Sorry. I'll jump back. I'm jumping around. Make is just a program that's on a lot of Linux systems. It'll let you might have to install it, but it's just a process that reads a make file and does those commands. There's nothing else really to that. So that video also leads you to a Spooky Scary Skeletons remix, in case you're wondering. But anyways, back to it. So if we, looking at this, we see the .stdio, which is why the file wasn't showing up right away, because it's hidden. But we can see right here we have .stdio. So if we look at that, we can see a bunch of defines. So it looks like the kind of encrypted saying for the story. So if we were to actually go through it and change every single line to a new line, it would give you the original source code for the program. Which, I don't know if I actually kept it, which is kind of sad, because I don't really want to go through it too much. But if you went through it line by line, you'd see that it's doing a simple XOR on a given string. That's a shame. I'll toss it in. I'll go over it and toss it back in the OffSec channel if you guys actually want to see what the original code looked like. But what it's doing is it takes this is actually the flag, and XORs it character by character, which, yeah, I think I should just be able to, I'll try something quick, little test file. So what actually was doing, we'll have our char string. What is XOR? XOR is exclusive OR. It's a binary operation. So if we went to our calculator and you had a number 25 and XOR'd it with 26, you'd get 3, because if we looked at the binary of, oh my gosh, 24, if we looked at the binary, what a XOR does is it takes every bit and only sets that bit if the other bit isn't set. So if the bits are the same, it'll make it false, but if they're different, it'll make it true. So 24 XOR'd with 23, is that what I did? I'm getting lost now.
Either 24, 25 with 3.
Alright. But yeah, now I'm going to set 1 because 24, if we look at those bits, we have 1, 1, 0, 0, 0. And if we go back to 25, we'll see 1, 1, 0, 0, 1. Oh my gosh. Okay, yeah, that's XOR. So, what if after you went through it all, I don't think I tried to make it look too much gross after it's actually in there. I don't know if this will actually work. Nah, here. Let's do 1. So 4 x into x, which is equal to 0, while x is less than the string length of string. Just going to ask for that library now. So in case you didn't know, you don't actually need to have all these includes. If you just don't care about the, if you don't care about warnings, but if it asks for 1, it's going to ask for more. Just got the problems with string length. So going to xplex plus, then we can do string at x is equal to string at x XOR x. I don't think that's right, but I think it was something on those lines. %d, %s, I mean, on string. Got a little new line in there. Yep, that's obviously not it. Unless I did it. Might have done. Wow, that is positive. Oh yeah, this is getting more convoluted than I wanted. But yeah, that was a fun challenge. After you unzor it, everything, it would say something on the lines of flag written by Gib Elder, and that's the flag for that. But wasn't that one easy peasy? Okay, so we only have 2 solvers for this easy peasy one though. Oh, this is a good one actually. So this was also written by Chris, which at the time was a pain in the butt, which I guess now it's still stumped a bunch of people if they looked at it. But earlier, last week we mentioned to look at our kernel poppers GitHub for ideas on tools and maybe write-ups if they came in handy, which here one of the write-ups actually would have. And there's a lot of write-ups, but none of those. Maybe this one? No, definitely not that one. Yeah, right here. Intensity overload. Actually had kind of the exact same layout, just colors. So what you're supposed to do here is take this picture, which I'm going to open up in GIMP, which is a editing tool. Open with, where are you at? There you are. So what you actually need to do is find the hex code of each color, and then the hex codes would give you the string that you wanted to submit. So if we open up in GIMP, went to color picker, picked that color, checked out the color, we can see that the hex notation was 27254A, which I'm going to use CyberChef, which is another great tool you guys should use. Say from hex, and we'll go through this list, choose this next color. So as I said, this was from another CTF that I saw also, where they also had it as their hardest Stego challenge, which I recognized right away, and only one other person out of a couple hundred actually noticed it. So which means Chris is on the levels of a master CTF creator. This is not looking right so far, though. I might miss something. Oops. Oops. Okay, well right here you can see the first ones must not have been anything, and then we also have a repeat because I messed up. But you can see the brackets, and then heart Dakotakon, which was the flag for that. Yeah. So Stego can be a pain in the butt, and you can spend hours on it, but it's just kind of trial and error until you actually figure out how to do it. So next we have phone, crypto, or Stego. Or, no, we already did, or reversing. So a lot of reversing ones. Crypto? Okay.
Hey, Mark is back there.
Yeah, he is. He's a...
You want about the Python.
I was one of the two people, yeah.
Yeah, right there, Mark. Or people, he's one of them. So this was also repurposed from, I guess they're all repurposed, so I can't really say much on that. But this might also require you to know a little bit of Python. So we can see we have this where we have the public key, this small number, which is, we didn't really think, so the question was, why isn't the site optimized for mobile? Kirsty's actually talking about your site, looks like.
Oh.
I don't know. Why isn't this site optimized for mobile?
Watching this stream and stuff on your phone.
I don't know. So, anyways, and we have our encrypted text. So this is our Python file. We can see that it prints out a public key, which is P times Q, and then our string of E. And then we have get input, public key, which prints out the public key, and then the encrypted text right here. So, what I did for this at first was change directory to CTF. Ooh. I think this one might be in var. Yeah. Nope. Okay. So this is another one that might be out there, unless I go into it pretty densely. Darn it. Okay. So what my solution was to actually solve this was I took the easy-ish kind of route, is that I don't need that one anymore. Don't need that anymore either. Is I split these up kind of just like every new line. Did that with sed pretty easily. Just replace those with new line. Don't worry about that. Don't ask me questions on sed. I'm not a master. What I did was, since P and Q are static in this case, and this is a really small number, we could brute force it because only one. Because yeah, it's pretty much only one or two solutions that actually give you P and Q. So if you had a simple for loop, it'd probably, I could probably type something up pretty quick. Yeah. Sweet. Slash RSA. 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 There we go. Alright. So what I did pretty much was just counted out main, did 4x in range of, I don't think I did it binary search way, but so we know that it's at least, it's going to be smaller than this for sure. So you can just do a simple for loop saying in there, then for y in range of the same thing, which I'm just going to divide by 2. It's a safe assumption. And then say if x times y is equal to that, let's print x comma y. Hopefully, okay. Didn't nearly take that long last time. Oh no, I got better. Okay. Those. Yeah. Okay, so what we do know though is that P and Q are prime. I should have gone with that so I didn't actually have to check every number. So what we could do is only if x is prime, if that's actually the function, underscore prime. Now these aren't necessarily the most efficient ways to do it, and this divided by x is prime. This will give us our x and y. Or not, because x wants to be 0. Makes sense. So let's do that, and let's also increment by 2. We'll start 3. Wow, that's not what I was hoping for. Okay, let's ignore that. So, I know I figured it out. It's a little embarrassing, guys, I'm sorry.
The two numbers are prime. You're not seeing if those two multiplied are equal to.
Didn't I?
No, I don't think so.
Whoops. Vim RSA. Yeah, so we're checking if x is prime, and then if this would be y is prime.
You're just going for all the primes that are under that number then.
No, because this would mean x times y would have to be would have to equal that.
Oh.
But that obviously did not work, as we can see. So, after some, this worked a lot better the first time. What did I do? Anyone that did get it, Mark, you want to give your rundown of how you found P and Q?
So, I mean, within the little key that you're given, if you go back to the actual problem statement, there's two components to it. So the bit that you just highlighted. So all you need to do is just factor that thing, right? That's all you're trying to do right now. So that looks like some P times some Q.
Yep.
So you should be able to just run through all of the numbers up to the square root of that number, and then just try to divide and make sure that you get just something. So all you need to do is just do a test, take that number divided by x, see if it kicks out a 0 remainder, and then it gives you one of your vectors.
Oh, yep. That'd be it. I'm not checking to see if it's actually a good division right there.
Yeah, you're just going to try to see if it divides nicely.
Yeah. Okay.
And you can be lazy and take, that number modulo x and see if it returns 0.
That's what we'll do then. So mod x. And if that's true, so mod is the remainder from a divide, if you guys didn't know that. So if you did like 4 divided by 3, the whole number would be 1, but the remainder would be 1 also. So mod would just give back the remainder instead of the actual division. So here we should, sweet. there, yep, equals 0. I was getting every wrong answer. We get the only two possible answers, 1433 and 3389. So what you could do is actually put the encrypted stuff into a list and then go through the decryption process, which is pretty much just the same modular kind of stuff, but in reverse with a different number. So maybe you can't. But what I did was get rid of that. Okay, get rid of that. X is equal to 1433 and 3389. 1433 and y is equal to 3899. 3389. Okay, and then we can do, because if we go to the encrypt string, we can see that it takes the public key and then the string. So what I actually did was just did a little alphabet string of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. And then for X and A, we do encrypt. Actually, I don't even know if you need to figure out X and Y for this. Yeah. My bad. So if you just took the actual X times Y, which in this case you wouldn't need to actually know, and then printed it, because I think it returns a string. It returns that, but I think that should still work. Fingers crossed, it did not work. So let's just send in A instead. Still did not work. What don't you like? Int object has no attribute split, so it's trying to split our... Oh, it sends in the public string. Okay. That would be why. So let's just set this to... Let's just get rid of that. Oh, yeah, because it needs a mod too. Yeah. So, as you know, I'm very cyber in this kind of things. So I'm just going to hard code that guy in there and say 139. So what you could have done is actually decoded it, which I'm guessing which some people probably did. Trying to mess that up now. But if you were smart, you wouldn't actually need to know any of that, which, not calling anyone not smart. You could have actually just taken the encrypted stuff already, and then it'll spit out every single character, so A, B, C, D, and then you could do something stupid like what I did and go character by character and match them up, which you would then get your flag. So if you want to do some fun matchup, go right ahead. But there is a Pythonic way to probably go through this all, but I'm going to call it good there.
I'm going to go with the .x one now.
Sure. So we're going to go through this What's Up Docs, which I thought was a pretty clever title that I made up. Yeah. So it asks you to submit a file. You can grab an example resume. And if we look at it, we can see that we have Dwight Schrute as an assistant regional manager. So if we just like choose a file, go back to
I have no idea why.
Well, that's malware. Cool.
Makes sense.
But anyways, that's supposed to return a resume with some stuff just appended to it.
It depends. Like, your resume is great, you're hired, so add that to the .x file.
Yeah, so what a docs file actually is a zip up directory. So you can actually go into it and actually look at this stuff. So what you need to do was edit the actual body of this. So if you look through it, you can see Dwight should be in here somewhere. There he is. So you can actually see the text of Dwight Schrute where it's written. So what you need to do was, I don't actually know.
I can just...
If you want to come up and just type it, because we can't actually submit it on my computer.
.x files are basically just container files that contain a bunch of other XML files within it. So basically the vulnerability here was just an XXE. So it was
So XXE stands for
XML external entities. Why is your shift button not working?
because you have caps lock on for some
Oh,
reason.
why did classic?
Just turn caps lock on.
No, I don't want to.
Okay, so what he's going to do is actually add some malicious XML code where when it runs the doc file, it'll actually run this code and read through the directory and give us stuff like.
Gosh, I can't type.
Now, this was pretty high level, as why it was one of the higher points, and Shane was the only one to actually get it, and because of that, he got a prize too on top of it. So good for him. Yeah.
So then we can find like the bottom, and then we do like.
So then what you had to do is create this doc type object and then reference it down below. And then doing that should.
You'd save it, and then you would rezip the.
So 7-zip
Yeah.
will tell you like, oh, you
So you don't
changed it.
update the
so
archive,
you
so
just
then
say
you-
yes.
Yep.
Then boom, it's fixed.
And then when you re-upload that resume, it'll try to like add the comments, so it'll parse that docx file, and it'll have the flag in it because it reads it from the file system.
So, but it's malware on our network, so it's another problem if you're trying to actually do it, is that a lot of the web challenges can't go through DSU's network, which can be problemsome.
Sad boy.
Yeah. But I know I spent a lot of hours trying to do that one, and I just deleted my slides. Okay, so that's all of that. I see air. This one's probably not, oh man, only 2 people. Maybe this one was tougher.
I made this one also.
Chris made this one, and at the time I kind of hated him for it because
It's pretty awful.
it starts off really easy, and then you get kind of upset after spending 6 hours on it. So after seeing this kind of text, does anyone initially just instantly recognize it?
Brain.
Yes, this is Brain F. We'll do a stream safe,
Don't demonetize us.
which is a programming language, esoteric programming language where, close your eyes everybody. Just do online.
You should copy that sh/.
So if you actually run it, finishes pretty quickly, gives you something that looks like a flag format. If you tried it, you'll get it wrong because that's not actually the flag. Come on, there we go. But the reason this is in crypto, which should have been another hint, is if you look back, you can see I see air, which should have been your hint for the Visionaire cipher, or Visionaire. I don't actually know how to spell it. Cipher.
It's like VIG.
There it is. So this was a World War II, I think, French cipher, but you need a key. You could probably figure out that, hey, the first letter needs to be a D, and then the next ones need to be DCTF, and then you get IAMT, but kind of confused after that part. So after a while, you're like, oh, maybe this guy. Is that anything? What's his name? Cool. It's not that. That sucks. Now what? But if you look back very closely, you might notice IAMTHEKEY, which spells I am the key. Oops. The key, which gives you visions of the past. That was a little out there, which was the reason Chris made it, which is also good. It's a good challenge, but if you didn't put the connection together for Visionaire, you would have lost it. Or if you also got stuck at the key, you would have lost it again. Okay, we have pwn and reversing. Which one's next? I don't have to go into all of them either, if you guys...
Is there any problem that people like really wanted to actually talk about? Like something
Yeah.
that you got stuck on instead of just some random one.
So I'll just start at reversing. We have another
You gotta
Python.
do one of each.
Yeah, I can do that.
Rubik's.
Oh, did you get stuck on that one? Sounds 2 years old, Jared. Come on. Okay. So we have this Python code, which might make you need to understand Python, but it kind of reads. It'll say, has this guess, which with some numbers, which might give you a hint to the flag. But right here it says system argv, so it looks like you need to have arguments. You need to put in your guess for the flag. That's weird. I'm not actually sure why you need that if the guess is down here. Okay, so ignore that. You don't need arguments. But it takes in your guess as raw input, which is just Python's way of reading a string, and then sends it to guess. Here, it takes in your guess. If it's not equal to 22 characters, it returns false, which means you failed. And then it goes through this, it enumerates through the list, and we'll do a little XOR with 209 on your, yeah, on there. So XOR works two ways, where if we come back here, actually, I'll just edit it in Python. Bless you. I'll do decrypt.py. So when we get up here, we'll actually just do this, where instead of it returning false no matter what, we'll just have it print out the XOR value of the list. We'll need vowels for I and vowels. We'll do a print of the ordinal, not the ordinal. That should be, yeah, that should be fine. All right, the print of I XORed with 209, which I think that should give it to you. Whatever our flag is, oh, gives it back as, I give it back as ordinals. So if we just convert it back to a character, we'll get flag Python underscore is underscore useful. So a little simple Python one. So we have cow.exe, which I don't actually know why Jared is so bad.
That's the only reality. I've asked like 20 questions.
So I tried to make it so some of these could be done if you didn't actually know assembly, but a lot of these just jump straight into the assembly, it looks like, yeah. Which we'll get into, I guess. So cow.exe. .exes are usually Windows. If we run it, looks like we can't run that because for some reason it's written .exe, but it's actually a Linux binary. But if we open it up in IDA, we can see what's actually, see what's actually going on. So this is assembly. We can see main. This is what main will look like in grossness if you don't like it. But this function call isn't normal, so we'll actually follow that. And the best way to, I think, to follow assembly is just to look for the calls and then see what's actually going on. So we have a printf, we have a set, shift, verify, and then I'm guessing if it's right or not, we'll get the flag or we don't. So if we go into set, it looks like it just asks for a bunch of get chars. Whoops. So it checks to see if it's a yes or no. How can we tell if it's a Windows executable? There's a couple ways. Sorry to jump around, but I got a question saying, how do you know if it's executable? So there's actually a program called PE Studio. You can jump that in there, which if it is a PE, it'll tell you and it'll give you a bunch of more stuff, which right now it is not a PE. If you look at the strings, you can see stuff like x86, you're not going to usually see, or glibc, you're not going to see that in a Windows binary. Otherwise, if you run the file command, it'll also tell you. But anyways, whoa, I lost it. Okay. What is an ELF file? So an ELF is a, oh, it's gone, it's okay. No. So an ELF file is pretty much just Linux's executable file. It's just the format they gave it. They call it ELF because, yeah, so if we just grab the head of RE2, that's not the head. Oh yeah, it is.
There's some new lines.
Oh yeah, right here, ELF. It's just because the first three letters say ELF, so that's why it's an ELF file. And it just says, hey, I'll run on a Linux system if I have the right stuff. And then a Windows are called PE because the first two letters are PE in theirs. Just kind of like stuff to just to show like a quick check to be like, hey, on this file I'm working here. So ELF stands for the format of executable and linking format. So that's some useless knowledge you know now. So we're getting a get char, and then it's checking to see if it's a yes or no.
Roasted.
Okay, that's true, but they don't need to know that. I was just proven wrong for the PE stuff, but we're not going to worry about that.
Testing this guy.
So we're just going to check for a yes or no. If it's a yes, it'll add 100 hex to EBX for the first one, 80 hex for the next one, 40, so on. So if we go back to shift, it will do some shifts where it moves into ECX beef, and then shifts it left by 10 hex, which is 16 bits, which is kind of just a midway point for 32-bit binaries. And then it calls verify, which checks to see if DX is 155 hex. So I'm guessing, just like based on running through this, that our yes and no's need to add up to 155. So if we go to DakotaCon, done, cow.exe, we can say yes, no, yes, no, yes, no, yes, no, yes, no, yes, no. Whoops. And that was actually the correct format on accident. So if you put in that, because if you put in something not that, you don't get the right flag. But it looks like it wanted one yes, one no, one yes, one no, one yes. Or if we go to a calculator, so if we go 100 hex, then, oh yeah, I don't know what I missed there.
Calculator.
Oh yeah. So we have the 100 hex plus the 40, then it goes 20, then 10, then 8, then 4, then 2, then 1, which is 155. So we accidentally got the correct output. So if you were just like accidentally fuzzed it, you would have gotten the correct thing. Reversing, so that's South Dakota's main enemy. So we have those sweet addictions now, which is coffee.
That's a virtual market.
So this is what, oops, that's not going to run. That's what most Linux stuff, Linux binaries kind of look like when you download them on Windows. It's just, hey, I'm a file. What do I do? So we can open that one up in IDA. Let's close the last one. Let's not save all that garbage. In this one, so a lot of these have the same layout, so we can just jump straight into set again. Not set, but verify. And here we can see that we're checking for EE. And doesn't look like there's anything different with shift, I don't think. So to get EE, if we go into hex, go EE, we want 238, but can't really do that. So what we need in hex is pretty much 1515. So which is no 8 plus, oh, that's broken already. So I put new lines. The get chars will eat the new lines. So we don't want the 100, we want the 8, we want the 4, we want the 2, we want the 1. Yeah. And then we don't want the 10. Yeah, we do. No, it should be 8, 4, I think. All those ones. That's not right. I think. So 100, 80, 40, 20, 10. That should be 15. That should be 8, 4, 20, 2, 1 again, I think. Alright, so I'll open it up in GDB. GDB is just a disassembler. I used the wrong one.
Yeah.
Thanks for the heads up. Yeah, I was running the wrong one. I wanted coffee. 8421, 8421. Darn it. Thought that'd work. But anyways, so GDB, this is how mine looks because I have a special plugin for it called Pwn Debug. Jeff's also out there, and so is Pwn Tools. This just makes GDB look not gross because normal GDB is disgusting and hard to work with. But you don't really need to worry about too much about most of the commands. But I did a B main to break at main, then continue. And I actually want to break at verify. Just continue there, and we'll do no to 100. Yes, 8421, 8421. So this will bring us to verify. We can actually step in to see what DL is, which is FF. Huh. That's not right. But anyways, not well EE. So we need to figure out how to get EE in there. So we're probably gonna have to look back at the shift function and see what's actually going down here. We can see that our argument is passed into EBX and then shifted left by, shifted left by 16 bits, so the high order. So if we had EE and then shifted left by 16, that's 16, we'll get this. This is what we want. And then it looks like coffee is added, and then ECX is also shifted left by 8, and then we order them together. Why is EBX shifted left? Whatever. So as you can see, I put a lot of effort into planning this out beforehand. So let's break at shift. We'll delete our first breakpoint because I don't really care about main. And yet it still came to main. Delete 2. Yes. Let's give it like all guesses to see what we're working with. So inside shift, if we grab our value in EAX, 1FFF. Oh. Oh, I was one off. Oh, that'd explain it. Oh yeah. So what I was doing was 8 plus 4 plus 2 plus 1, which is 1 too far. I actually need to not do the 1. So if we did coffee, did no, yes, 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 no, yes, 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 no. Darn it. Okay, let's go through this one more time. No, yes, 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 no. 8, 4, 2, yeah. No, yes, 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 no. So let's see what we're working with. EAX is EE. Did I just run the wrong file again? So when we return EAX is coffee, we'll go into verify. We'll compare DL to EE, which DL is EE. And we compare BL to 1, which is 0. So that's the part I missed, is that we never actually checked to see what BL is. So if we go back to shift one more time, which was probably just in there. When it shifts, that's what this shift is for, I think. Nah, that's what this rotate is for. So rotate does is instead of shift, so a regular shift will grab all these bits. So like if I shifted right, a shift would just kill this byte. So like if I went, or bit, if I went right 1, this doesn't go anywhere, but if I rotate 1, this now gets pushed to the beginning. So what actually needs to happen is that the first bit needs to be a 1, so then it rotates around, we can get it. So if I do coffee 1 last time, I put a yes for the first one. 1, 2, 3, 1, 2, 3. We'll get 01 coffee. That was a little bit more than what I'm able to handle because I'm a noob. But someone else was able to get it quite easily, it looks like. Oh, 3 people. Alright, so now if we go into elite reversing, this is another NCL problem. Open this guy up. These actually aren't as nice to work with because NCL, but they're not too bad. What we could also do is open this up in Ghidra, which would give you like a disassembly, but don't really need to for this. So if we look at the calls again, we can see that it's asking for an extra parameter when we run it, then checks the string length to make it sure it's 4. Then if it's not, it prints out error and then exits. But then it asks for a password, gets the password gets, and then it goes to FG if it actually gets something returned. So here we can see a bunch of stuff and garbage is happening. And what we're looking for is, passes in argv, which is our password that we put up first. I don't think it ever actually passes in this. Yeah. So if we actually go to the binary, change directory to NCL. So if we ran, so this is oh gosh, it's not in here. Okay. Share / download / RE. It was just RE, wasn't it? Oh, RE_1. Come on. Oh, that'd probably be it. Thank you. Can't really change there because I don't think I'd have to give it allowed. RE1, copy that here. If we ran file on it, this will give you like say, hey, I'm an elf, so you can run it in Linux. So we can give it a run. It's asking for an extra password, and then another password, and say, hey, you're wrong, try again. But if we see we have this leet 1337, I'm actually going to need an extra password too. So we're going to find another thing. Close that. All right, so we get the string, and then it compares the string to 0. If it's not 0, then it does. Okay, that's why I failed. If I need to get something not... Oh, what? Oh, no? Am I missing something?
I had to jump to the function myself in GDB.
For this one?
Yeah, and then reset the stack.
This one shouldn't have.
Wait, I got the black
A, B, C. Huh. So it compares the D word at 3C to 0. Oh, which, yeah. Because right here it's setting it to 0. So it's checking to see if it's 0, even though it already knows it's guaranteed to be 0, which means it's never going to happen. So what we could do is do some nifty little binary patching, or if we did GDB RE, we did start break at main, continue, and that's not going to work. Start with our leet password, and we run all the way through to where it does a compare, which CD, which is right here. We can actually just set this to 1, so it actually fails that compare. So if we print $ESP plus 0x3c, we'll get this address, and we can set this address equal to 1, and then we'll actually go into our call, where if we continue, we'll get our flag. Yeah, so I think that's the flag for that at least. Oh, great, okay. As for the 9991, that was kind of on the same terms, but for some reason I got a different answer twice, so I'm not actually sure what's up with that one. As for forbidden entrance, close this item. So this looks like another one of the other ones. We just have to check the verify again, and we're checking, we're doing maths this time. Oh man. So what we could do is actually go through this line by line and figure out what it wants us to have. But it looks like it's not actually reading in what we pass it. So what I'm going to do is just run through the program and see what maths actually equals, and then just go from there. Codicon, change done. LSGB of forbidden. Oop. Set a break at maths, and we'll run it. We'll just give it a bunch of yeses because we don't care. Then in maths, we can skip all the way to the end where it should return an EAX, the value it wants. And copy that. And we can actually see what it's actually doing with this value. So it looks like it's moving it and then compares it. So it looks like our value needs to equal that. Where if we go back to shift also, it's also adding the 4B, 1D for us. So it looks like we actually only need to have 4B, 1D. Looks like we need to have the 1 and the 5A, I believe. So if we do forbidden, do 1, no to 8, yes to 4, no to 2, yes to 1. And then we also, what was our 5A? Yeah, I'm at 5 there. So we need A, so we need no to, yes to 8, no to 4, yes to 2, no to 1. And we'll get our flag. I think, yeah, that's right. Yeah, so that's another binary math one. I guess it would take, they're not easy to say if you don't know how to reverse, they're pretty much impossible if you don't know how to reverse engineer. So 999 different solutions, I'm just going to skip that one because I can show you what I did the second time, but not the first time because I kind of forget. But dodge, dip, duck, dive, and dodge. Oh, Jared got it. It's pretty good. So I'm pretty sure Ivy wrote this one, I think. You made this one? Oh, that's even better. Chris is on fire with his challenges then. So I was really confused on this one at first because if you open it up in IDA, if you open up in Ghidra, it doesn't do anything. It just says half the program you can't reach. Chris, are you single?
No.
Oh, sorry guys, he's taken. Oh yeah, anyways. This looks like a, just tossing this in, we'll get a little string that says sub to PewDiePie. And also called the random, which you don't really need to worry about too much. But down here, what we do worry about is that we're checking this value for 0. And then down here, we're checking for 1, and then 0, and then 1. But there's actually no way for us to actually change these values with the program. So just by running this, no matter how many times you run it, it's impossible to actually complete. So what you're actually going to do is, for this one, you actually need to open up in some kind of disassembler or like GDB or something. Break at main, we'll go continue or run. We'll go down to the first one because the rest of it doesn't actually matter. Right here. What I did was printed out the value of RBP and then did a little set this value XOR equals 1, so I can just keep coming back to the same line without having to worry about it. So if we actually printed out what was at this line to make sure it's right for the first one, we can see that's 1, which is what we want. So now we can actually go into, nope, I failed. That was not what we wanted. We wanted 0. So let's start that again. Yeah. So I'll print it out again. So we're at 1. We actually want 0. So now we can actually go through it to the next compare. Takes a little bit to get to. There's actually a way in GDB to set a breakpoint whenever a memory address is accessed. But the problem is it'll only show it to us after it's accessed, so we'll already be past the compare. But you could have also done is set the flags. Flags, for those who don't know, are just like kind of tiny registers to say, hey, I just did like a compare, I'm now 0, or I might have missed one. Yep, I messed up. Sorry guys. To run through it again. So the fun thing about this is that you have to either get them all right the first time or start over. Oops. And I missed it again. Alright, right here. So let's print it out again to make sure it's right. There it is. It's a 1, we want a 0. We can do that. We can step to the next instruction. So the next compare. I mean, you could have also actually reverse engineered this, which I did for the most part my first time running through and got a bunch of the characters, but I got lost in like this big block of math right here because it's really gross. So this is by far the easier method. Jared, is this what you did too?
No. I would get to the compares and just jump over them.
That's that'd work also.
No, it was way worse. Because like every single time you get to the jump not equal, GDB would decide to show me the tree I'm going to take, so I couldn't even see what the next address was. So I jumped back to get rid of the tree and then jump forward.
Somebody else used to, apparently there's a skip instruction.
Is there?
Yeah, I've never used it before and I don't know the syntax.
Skip function name. Ignore a function while stepping.
So I don't know how they were able to use it.
That's pretty cool. I just lost my train, and I don't actually know if I'm right or not. I think that's right. Okay. So yeah, this is just a matter of getting through the whole program. Lucky for us, it's always checking the same address. Otherwise, we'd have to jump around like Jared and...
Yeah, that guy.
Oh. Alright, looks like we're at the end. And if you continue from there, you'll get the flag. Some crazy stuff, some reversing. Rubik's Code. Oh. Yeah, okay. Did I give you the... There's source code in there, isn't there?
No.
Oh, did I just give you the binary? That was
Yeah, I
a
remember a
little,
couple years ago there was source.
that was a little mean of me. I should have given you the source. That's my bad. But
How's that guy solve without source?
probably got the binary. I mean, you can SSH in there, can't you?
Jared, you have to be good.
Could you just SCP?
I think. Let's see.
I was trying to do this blind for about 5 hours. I would just send back random bytes. I like
Oh, dang, yeah. That's... Okay. So, I might actually not show this one because you're supposed to have source. C source, I think. Yeah. You're supposed to have the C source. And it was not there. That is my bad.
That was all yesterday. The whole day.
Good job for that guy.
How would you do that? I don't know. Well, if you look at his name, he's a professional. So.
He is a professional, just a professional CTF player, playing for the Kicks. I guess we're the Kicks. So, we're going to memory hunting. I thought I actually put the source in there. It's my bad. But I guess what you could have done is, if you were smart, is you could have SSH as challenge 7, which not everyone knew what challenge 7 was, into ctf.offsec.club. This is mostly directed towards Jared because
He's doing this from home.
I am. Challenge 7. So there was a hidden pwn challenge that once you got the others, another one would show up, which had a different password, so you couldn't just automatically guess it. But if you change directories to Rubik, you could actually see his code, and you could have, executed it from there and read it. So if you really wanted the source code, you could have found it, but it doesn't look like Jared really wanted it. So I'm actually gonna.
Maybe that's how I found it.
It's probably
If
how
he
you
did
found it.
that blind, I'd be really.
There's no way he did it blind, because with what you need to do, there's no way you'll guess it.
I was just throwing the lights.
Okay, so we're back to the memory hunting. I think this was another. This is not. Oh, how many people actually got this? I think Jared was actually.
I think he got it too.
Yeah, he did. Okay, so this was. I think this was made by Jacob, or what we were told was made by Jacob. I think for DakotaCon last year. And no, this is not the same. Is this one?
Yeah.
Yeah. Oh yeah. So what this actually does is it reads in a number, and then wherever that number is, it'll edit the actual binary. So it'll go into that place in memory and change that specific byte so it actually has a different value. It puts the number 13 in there, I think. That'd take a little bit more actually reversing. But you can see here that you have this gibberish string, which you could have worked with and actually found the answer, which is how I did the first time. Like, I never actually figured out the correct answer until after. But you can figure out that the simple operation that's actually done on it with this rotate function, like, hey, what's actually happening? But, so in function foo, just prints out if you're right or not. Meep is, I think, what you actually want to overwrite. Oh, here's Meep 2. That's what I was looking for. All right, here, this pretty much just gets the current file and fixes it so you can edit it. And scanf will put that into Meep. And then Meep you can have be wherever you want. So there's two ways to actually make this work. Is memory hunting. Okay. So if we put in a number, it says segmentation fault. Put in 1, illegal instruction. 2, 3. That's weird. If you went through GDB, you'd actually see that like at the instructions are different than the time you ran it last time. So if you wanted to brute force it, you could actually go through like, 4, 5. And once you got up to 18, you'd get the flag. Or if you had the string and you're like, this is weird, let's mess around with it a little bit. I just copied it. I did Control C instead of Control V. And since it's a rotate, you could be like, what other kind of encryption algorithms use rotate? And you can see a Caesar cipher after some looking. I don't know how to spell Caesar, so. He's not showing up. Oh, it's because it's underneath rot. Rot is pretty much the same as Caesar. And if you go through them, you'll see one that actually looks like clear text. Amnesia is no joke. And that's how you get that last reversing challenge. Yeah. I'm going to the pwn ones now. I think that's all we have left. I went over Welcome to the Jungle and finding many targets. The jungle grows. I didn't go over. So this one, it gets your input, and then that's it. So what we need to do is have x, and then it does a check for x equal to this. It's weird that it actually prints out that address because that's useless. But whatever. That'll probably just tell you if you're right or not. So the way this is set up is that on the stack is where the memory is stored, and input is actually right after x on the stack. And the problem with gets is that it never actually checks to see how many characters you send in. So if you send in too many characters, it'll actually overwrite X. So if we run one, SSH into challenge 3 club and Bane. Oops. You could probably guess that the file is just running right away. So if we sent in way too many A's, you can actually see X is equal to A, which we need to now equal to dead beef. So if we do a simple echo for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 for our first buffer, do attack E so we can get the, I'll do dead beef. I'll pipe that to SSH. Ooh, just copy that. Which SSH doesn't like doing this, but it will work. But you can see that this doesn't look quite right. We can see that we actually have fbid, which is how, just based on how memory is actually stored. fbid with an extra deed. So the way memory is actually stored, it's a little endian, which means you have to actually reverse the bytes and how it's stored. So if we did f beef, whoops, a ed, no, ad, da or de. See if that one's right, or we need to do there, yeah. So if you actually put in the string backwards, so we have EF first, BE, AD, then DE, it'll go into the correct order and be dead beef. So if we go on to 1,000 more things, we get another C file. This one is almost similar to the first challenge 2 right here. But we actually need n to not be just 1, but actually be 1,000. So there's a couple ways you could do that. You could actually print out 1,000 characters, like 1,000 C's, and then do that. But since I only allow you to type in 11 characters, you need to find a different way. So what this took advantage of was, let's go SSH in. This took advantage of the format specifiers again. So like %n and %c. So like %n will allow you to write however many bytes was actually printed. So if I did ABCD %n, that'll give us 4 into wherever the next memory address is on the stack. You shouldn't actually use this in a real program because it's really crappy and only used for exploitation mostly. So %c, everyone knows what that does, it just prints out the character, right? But did you know you could do, let's print out that character 1,000 times. And then if we did a %n, but this will fail because our current stack will have X on there, which %c will try to print out whatever's at X, which will be 0. But we actually want to write to X too, so we can also say, hey, write to the first address or first value on the stack with $1, and that'll give you your flag, and also print out 1,000 no bytes or spaces or whatever. Yeah, that's kind of, if you didn't know that stuff, you could have found it looking it up, or, but yeah. So buffer 3, binary 10, because you're actually going to get back into binary files, not just C source. If we open this up in IDA, did you ever have problems with this one?
I didn't have the 8-byte alignment issue.
You didn't? That's weird. So this looks like it just reads and gets into our buffer, which is on the stack at 10, and then that's it. So it looks like we just actually need to, oh, we also have this function called get shell for some reason, even though it's just a system call. So what we're going to do is another buffer overflow, but this time overflow the return address, because how the way the stack works is that when we first get into a function, the return address is pushed onto the stack, And if we're able to overwrite that and jump wherever we want. So if we take the address of get shell, which is 401159. So we want to go challenge 5. Oops. We're going to have to echo back into this one again. Do A, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 16 for the 10 hex. We're going to need attack E. Actually, I'm going to go into my Python for this to show you guys how to like make it do it automated also. Challenge 5. Python. Cat. That's a shame. Okay, well anyways. Here we can have Python. In this example, we're using Python tac C, and then print out the values. Tac C just means to use Python command line, so it doesn't open up a shell or doesn't run a file. And then the print right here will do 12 characters with A, then it adds plus 12 characters of B. You might be wondering why it's actually doing, because that's more than what we kind of saw earlier. It's like if we look back here, we can see that var 10 is actually 10 hex, which is 16 off. And what we're actually doing is putting 24. And that's because in every stack, there's also a push RBP right here, which means at the end and the leave, it's also going to pop RBP. So we need to add another 8 characters onto the stack. So if we were to run this, which that's not the right address, and neither is that one. We'll have to fix that. Put that there. We actually do challenge 5 at ctf.offsec.club. Come over here, change this to the 0x. We need to do the little endian also still to make sure that it's correct. Open that up. Go to get shell. We'll do 5.9. It's a little hard to see, but it's down here. 5.9 / x 11 / x 40. Then we also need to fix it so it's overwrites everything. So 8 bytes total. So we have 2, 4. We need one more. Oh, definitely didn't like that. Because I need a SSH in there. Password 1 bang. And we can see it didn't work, which is weird because it should have worked. And on Jared's, you said it worked at this point? You said you never had the byte alignment problem? Because I was having problems where I also gave a hint in here. It says, your math might be right, but leave 8 just to be safe. So we'll put this down to 16. And we'll log in. And it'll actually give it the flag. So what was happening was that this version of libc was actually crashing before it would print the flag. So it was doing the correct overflow and everything, but it would crash. But then what would happen is here, I'll toss it into a file. Temp GDB at challenge 5. Oops. Buffer 3, I mean. GDB, oh, it's not gonna work on this one because I have a different libc, but I should be able to still show you. Start by piping in temp. Make this larger. So if we're stepping through here, we'll get to the gets and we'll write onto the stack. So here we can see our stack. So we can see that we have our get shell function right here. But usually that's pointing, RBP points to this, but usually we want this one to be it. But for some reason it crashed on the program. So if we actually get to the ret, don't think it'll do it in this one. Yeah. In the actual, well, it's because I overwrote it, so I think. Anyways, in the other libc, once it gets back here, it actually does a call RBP. So whatever's in this value, it'll just call it right away. So that's the reason it will still work. But problems will be problems. anyways, we'll go on to free your mind. I actually copy that one too. Go back up. I'll copy this flag so we can actually submit that one, because this will unlock another challenge for us. So here, free your mind. This one was written by Jared during a conference when you should have been paying attention. But I think in the original he might have given you source code. I don't think we have it this time. I could probably show it to you, which I will. But here we can see that it prints out a menu with all these. Then based on the choice, it looks like it'll do different techniques or different values based on what you chose. So if you actually knew a good bit about reversing, you'd be able to follow the lines and see what's actually happening. But we have the actual source code, so I'll just show you that, guys. Challenge 6. We'll open challenge 6.c. Here we have a get flag function. We have a student info function, an admin info function, some structs, main, which is the menu, and then based on the choice, which is a gross looking switch statement. And it looks like based on the choice, you can actually do different stuff. So if we interact with this challenge locally, let's make an admin, because let's just see what we got. We can then print the admin data. Looks like we're an admin. If we print the user data, it breaks. So that doesn't really help. We can make a user. We can print the user data. Looks like I'm a student. We can delete the user. So if we look back at the challenge, whoa, wrong one. All right, so we look back at the challenge. We can see that that admin is actually set to flag. We just don't have a way to interact with the flag based on these choices. Because if we look up here, the admin has those two, and it looks like flag is first, which is a good thing to know for us. And then the user is those two. So a good thing to have noticed, or like just messing around, you have seen the segmentation fault with user, which means there's a use after free. So if you actually freed it, so if we created a user and then freed the user, we can actually still print the user data, which actually got deleted. So that's why it's segfault. But we can actually still interact with the user because the pointer is still there. So if we create a user, okay, create a user, delete a user, create an admin, and then interact with the user by printing the user data, it'll actually print out the flag, because the way the memory is set up, go back in here, the way the memory is set up is that when user is created, it'll give user pointer the address in memory to where the struct is pointed, but when we free it, this memory space becomes available now. When we create admin, admin gets put into the same memory space, and now admin and user both point to the same memory address. And since the user info is the first variable and so is the flag, we're able to just print out the flag. So if we actually SSH in 6 at not pwn CTF offsec.club, password 1 main, we can make a user, delete a user, make an admin, print the user info for the flag. So that's just a simple use after free. If you've never seen one of those, it's kind of hard to understand what's going on. But in C, memory management can be hard. Where's pwn? There it is. So now that we got those two, Finale opens up, which gives you a libc version and the file. So if we looked at the file, we would see that's the exact same as binary time, pretty much. But we can actually SSH in this time as user 7. We'll get password 2 at. So this one's actually a little bit tougher. If we look at the file itself, we can see that buffer 7 has a set group ID bit as flag. So if we're running it, we're able to actually access, we might have a chance to access stuff from flag. And if we go to flags directory, we can see that flag.txt is only readable by there. But, so let's just abuse this the same way we did buffer 5. Yeah. I will remain open for us to try again later. We can keep the CTF open for a couple more days. So if you want to keep working on them.
I think you should be able to submit right now.
I think we set the, did you fix the timer?
I don't think, yeah, the scoreboard should be frozen.
Okay.
You can submit.
So your score won't go up, but you can still work with these. Well, anyways, go back to this. I actually want to go back to challenge 5. I want to copy that same buffer we actually sent in last time. Right here. I don't think that'll actually work. But if we change this to an echo, it sure would. Or a printf. That'll work. Well, let's just call printf on this guy. That won't work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Get rid of those. Get rid of that. So now we have just an easy way to actually copy this into the other terminal. When we SSHN. Password to @ So if we did this and then piped it to buffer 7, we got a seg fault. That's not very cool. Oh, darn it, these addresses aren't actually the same. Do a quick little check because they're slightly different with that little string getting printed out. So if we went to get shell, it's actually at 40.11.75. What we did was 40.11.59. So change that to 75. And it still didn't work. So I think 1, 2, 3, 4, 5, 6, 7, 8. Well, darn it. Well, anyways, if we did the exact same method as last time, it would read the current flag that's in this directory, which says, sorry Mario, the princess isn't located in another castle. Try /home/flag/flag.txt instead. This is where it gets a little messy and how to explain it. So this is Vim. Guess I already have it open. Alright, this is my solution actually. Here's some ROP gadgets. And then here's 2 different solutions. So what we actually need to do for this one is control the code execution where we can call our own functions, and not just the functions that are in the same file, but functions in libc like get file, open file, system, set UID bit, set GRED bit, and that's why they gave us this libc file, because this is full of all the functions. So if we did a object dump -x on a libc, not -x, dash T, okay. Thought uppercase X or something. We can see here all the different functions. We have realloc, free, we can call malloc, but they're all at different offsets because the addresses aren't always the same. So what we need to do is first find out a way to figure out where libc is actually loaded into memory. Because if we did GDB of buffer 7, start and did a VM map, this actually shows us what address everything is loaded. And because of the way the binary was compiled, it will always be at the same addresses. But down here, these libc versions, which I'm at 2.9, that's weird. I was at like 2.8 last week. These addresses can always be different, and there's no way to actually control the way these are loaded. So we need to find out a way to leak these. A good and useful way to actually leak these is to look inside the GOT table. Darn it, the GOT. This stands for the global offset table. So whenever a function is called, it'll put that address of libc into that spot in the file, and then we'll always have a pointer to that function, and we'll always know that, hey, this function is at the same offset into libc, so we can always go that far into the function, and then, so we need to find out a way to actually print out what's at this address, which I think if we go to it now, it's just garbage because it hasn't been called. So you do a GX. Yeah, that's garbage. But, no, that's not even the right address. This is the right address. GX. All right, so this pretty much right now just points back in because it hasn't been called yet. But if we were to run our file after the puts and then check that address again, oh, I haven't called yet. Now we have this address in libc. So if we were to actually print out puts, like the address of puts, they're the exact same. So we need to find out a way to actually leak this address and then figure out what the offsets are and jump around from there. So with this libc library I gave you, or they gave you, could have been anyway, we can look for puts. We can, not just puts, but grep for puts. We can see that puts is usually at that offset of 809C0. So by saving that and kind of jumping around a lot and using the Pwn library, which is a Python library to help use interactions and send in binaries, control binaries. So our method of execution is going to be this. This is the, yeah, no, it's the wrong one. That doesn't matter too much. So in main, we're going to go to this return. We're going to overwrite the return address, so we jump to a pop RDI, and then we're going to jump to this puts. So the way this works is RDI will control the first argument when you call a function. So when we pop RDI, we're able to control what's in this function pointer, or what's in the argument for pointer. So if we put the address in of the GOT and then call puts, it'll actually print out. I'll get to that question in a little bit. It'll actually print out what's actually at this address. So that's what we're going to do is we'll do this little, we'll have to find some gadgets, which I used ROP gadget, which is just common on Calibox, and if not, you can find it on GitHub. We'll take our binary of buffer7, and then this will give us a bunch of different addresses and the different kind of gadgets. And in these gadgets, we find a pop RDI ret right here. So we're able to push that into the stack. It'll go there. It'll pop off whatever we want into RDI. And then we can return wherever we want, which is exactly what we need. So here, I just have these hard-coded values for the addresses. We have a pop RDI. We have the GOT address right there. And then I did a pop RBP because if I didn't, that would mess up our return address and stuff down here when we go through leave again. You could have probably circumvented this by actually calling the PTL, PTS, whatever address that's actually right here. But you don't really need to worry too much about that. And then we'll jump to puts, and which my puts was in here. So it goes through puts, and then it'll call gets again, which allows you to write to the buffer one more time. So what I did for the pop RBP is I did an address inside the heap, which it's kind of hard to explain off the top of my head, but if I do GDB of buffer7 again, VM map, this is technically the heap, this address. We're able to write to it, we can read to it. Sometimes you can execute in it, which can cause problems. But right here, if you just grab any random, not any random address, because this is also where our GOT table is. Gosh, our GOT is. So if we did like print those out, you can see that we have our GOT right here. So what I did was just did a spot right in the middle. I think I did 404.5, whatever. Quit. So if we go up to my address right there, yeah. All right, so anyways, the way this program is working is when we get to this leave, it'll actually move our RSP to wherever RSP was pointing, kind of, or not kind of, but exactly doing that. So that's why I use the pop RBP. So now I can control this to set it to this address. So I can kind of set up a fake stack sort of in this heap area and add these other ROP gadgets for it. So this one we don't actually need that. But in this case, in this first test, I just called set REGID, which sets the real effective group ID. Because if you just open up a shell, you'll be able to get the shell, but you won't have the right permissions to view the file. So what you need to do is change your current permissions to the permissions of flag, which you're able to do because the set group bit set group bit, whenever you run the bind. So what we needed to do was get into here, which this is just some buffering stuff. This is where RSP actually points to it first. We pop RDI again, set that to 1006. Pop RSI this time, we set that to 1006. And then we can call set REGID. Then we can call one gadget, which one gadget is another nifty tool. One gadget dash file for libc. This will search through the entire libc and see if there's any memory addresses where if you just are able to get to this address and all the constraints are true, it'll give you a shell. So we're able to actually control to make sure RSP plus these two are null. So I have the first one, I think. Pretty sure I have this one set. And after we find our libc offset with some math and doing all this, we're able to just straight up call that. And we can see that if we do an ID, our GID is actually set to flag now instead of challenge 7. So we can cat the flag. Flag, where you at, flag? That sucks. Cat, oh, try it again. Oh, and then you'll find out that you actually really did do it. So the problem with this one is Jared thought you could just, not Jared, I also thought that as soon as you got a shell, it would give you the correct permissions, and after some trial and error, I figured out that that wasn't possible. So my first solution was actually to just straight up open the file, which is what this much longer one is for, and it prints it straight out. Should work. So what I actually wanted to try with this one was try this new nifty system called send file. So instead of having to open it and read from it, you can just open it and then send the file, like the data straight from the file. So that saved me a little bit of my ROP chain. But yeah, and I didn't really explain it, but ROPing is return-oriented programming. So it's kind of just controlling. So what people used to do is just overflow the stack and then return to the stack, and then you'd be able to execute there. So you'd have full control once you got straight to the stack. So once people started making the stack unexecutable, whatever, you can't execute on the stack or the heap, you now have to return to wherever you want to actually control the flow of execution. So that's what ROP is where you just control a bunch of return pointers and just keep jumping to each instruction that you want. If you wanted to do more ROP, I don't actually know of any good ROP spots. Pwnable, that's not really ROPing though. There's a site called pwnable.xyz. Not many people are actually on this site. There's a handful for how long it's been out. Some of these challenges, they're mostly reverse engineering, like welcome. You think you just get straight up the C file. Open that. Nope, that's definitely not C. Okay, well, those ones might be tough still. If you wanted to get a little crazy and go to a Korean site, KR. Has this nifty little video that's actually really awesome about how you can hack Super Mario by setting up sprites in specific positions. Yeah. And there's a bunch of challenges here with some pretty weird graphics. Let's see if it actually logs me in. I've got a couple of these done. By a couple, I mean a good 50 or so. Mostly because these first ones, they're all like the website creators don't care if people have open solutions on the web. So you're able to actually go look up a write-up if you get stuck, so you can actually walk along with it. But these points, you are kind of out of luck unless you actually know what you're doing. I haven't really looked at them recently. But, so like if we looked at, I think file descriptor. I'm not actually going to do that, but. Huh, I actually know, this is new.
Hey folks, so today
Oh, cool.
we're going to be
Actually
going over
posted
the
someone's
ponables.
walkthrough on their page. I'll have to go look at that. But some of these are just like C files. You can read through the C and just see what's actually happening, just trying to interact with it and try and break it. Otherwise, if you just like search ROP challenges, ROP Emporium. Wow, I can actually know this is real. Gives you a beginner's guide on how to ROP. You can get some challenges. That's a lot of challenges. There's a lot of stuff down here. It looks like there's these challenges though. Cool. But yeah, that's. What's up?
It's just the natural gas leak.
Oh yeah. But that was pretty much it for the CTF. I think that a lot of those might have been pretty difficult, I guess, for where we kind of wanted the interactions to be. And hopefully next time you guys know more and and do more. Yeah, so that was kind of, the last one was kind of high level. But if you guys do have any questions, I'm free to help. Jared got a majority of them, but he did miss out on a bit. So I wonder if he's going to go back and fix those. He probably won't.
If I had that binary.
Don't do that one.
Oh, that one.
I guess you could do. Don't do that one. Save it for later.
Are you gonna give source?
I mean,
I'll say.
I give source. I don't think the source matters too much. I was supposed to give the C source. I'm not sure why I didn't. So I can actually walk through that one if you guys want me to, but I don't think I should.
Yeah. Then you just leave it for next one.
I don't actually know where it is.
Yeah.
CTF. Yeah, it's in. No, it's not in there. Yeah, it is. It's right there. Is that it? File E4. That's definitely not it. Well, anyways, any questions? Oh, fantastic. I'm glad I confused you enough to not know what you need to know.